First thing we need to know about probability are fractions. Okay, so with fractions, you got a numerator, you got a denominator. Denominator. Okay, now the numerator going to be events you are looking for, while the denominator total possible events or outcomes. Alright, now whenever we talk about events or outcomes, okay, say we're flipping a coin. Okay?
It only says guided practice 15 minutes.
There's two options, heads and tails. That means there's two outcomes. Right? Now, let's say we wanted to know the probability of flipping a coin and it landing on heads. Well, heads is one outcome. So for our fraction, we'd have 1 in the numerator, because that's the events we're looking for. In the denominator, total possible events, well, there's two outcomes. So we put that in the denominator. Okay? Well, 1/2 is equal to 0.5, which is equal to 50%. So we can say that heads will occur half the time or 50% of the time. Either one. Now, if we're looking to find out the probability of flipping heads 2 times in a row, alright, we'll be looking for the probability of 2 consecutive events. Alright? We're looking for heads twice. We'll define the probability of 2 consecutive events. The first event, which is heads, we already know is 1/2, right? The second event, which is also heads, is 1/2. Now, for the probability of 2 consecutive head flips, you'll multiply the two and get 1/2 times 1/2. Now, in order to multiply fractions, you're going to multiply the numerator by the numerator, so it'll equal 1 times 1, over multiplying the denominator by the denominator, so 2 times 2. 1 times 1 is 1, 2 times 2 is 4, so the probability to flip heads 2 times in a row is 1 out of every 4 times, which also equals 0.25 or 25%. So, flipping heads 2 times in a row would occur 25% of the time. So let's do another example. I want to roll a die and get an even number, okay? Now, even numbers like 2, 4, and 6, alright? The numbers on a die are 1, 2, 3, 4, 5, and 6. So, whenever we want to find the probability of rolling a die and getting an even number. Remember, the numerator are the outcomes we're looking for. So on top, the outcomes we're looking for are 2, 4, and 6, because those are the only even numbers on a die, which there's 3 of them, divided by the total number of outcomes, 1, 2, 3, 4, 5, 6. So, we have 3 possible outcomes to get an even number out of 6 total outcomes available. Okay? Whenever I reduce this down, it reduces down to 1/2, so I should roll an even number half the time, or 50% of the time. Okay. Now, let's say I want to roll a die. And get 4 or 1. Okay? I want to get a 4 or a 1. Well, again, the die has 6 sides. 1, 2, 3, 4, 5, and 6. And there's 2 outcomes we're looking for, a 4 or a 1. Well, find the probability. It'd be the 2 outcomes divided by the total outcomes, which is 6. So outcomes we're looking for compared to our total outcomes, alright? 2 over 6 reduces to 1/3. So 1 out of every 3 times we should roll a 1 or a 4, which is 0.3 repeating, which is about 33.3% of the time. Okay? Now, possible outcomes for a die are still 1, 2, 3, 4, 5, and 6. Now for an even number though, that's either 2, 4, or 6. So there's 3 outcomes out of 6, which is 1/2. And then a 4 or 1, 2 outcomes out of 6, which is 1/3. So to find the probability of rolling an even number and then a 4 or 1, we're going to take the 1/2 and multiply it by the 1/3. Okay? This is an event that depends on another event. Okay? The even number has to be rolled before the 4 or 1 is rolled. That's why we multiply it like this. So 1 times 1, because that's the numerator, then you have to multiply the denominator, 2 times 3. So the probability of rolling an even number and then a 4 or 1 will be 1 out of 6 times. Or 1 out of 6 is 0.16, repeating I believe, which equals about 16.6% of the time.